Section 9.2 is on a topic called series and deals mostly with summation notation. The main thing I want to say about this is while most of these problems are straightforward, students have a hard time with these problems because they don't master the language. They don't master the notation. And so we're going to be using a lot of symbols in this section. And what you should really focus on is learning the meaning of these symbols. And if you can learn how to read what we're about to write down, the arithmetic becomes very natural and very straightforward. So, you got to learn how to translate it. I mean, you guys know how to say no in Spanish?
Just no.
Well, yeah, it's not hard, that you didn't actually answer the joke right, but anyway, that's okay. I didn't prompt you up. Yeah, no, it's no. I say, do you guys know how to say no in Spanish? And you say no. And I say, well, it's easy. Figure it out. So anyway, ha ha ha. But I'll work on my delivery next time. And that'll get cut out of this video. Good stuff. So let's talk about summation notation. Before we were talking about a sequence. So a sequence that we saw was a list of ordered values, A1, A2, A3, ... up to AI ... and continues on. And you'll notice here that I'm changing the subscript. This is the general ith term. Now, a series or sum of these values looks like this. Now, this is, I guess, the first point of contention for students where they start to get confused. Sequence and series both start with S, right? And these look very similar. A1 plus A2 plus A3 plus ... plus the general ith term plus ... Now, if this continues on, this could be infinite, or A1 plus A2 plus A3 plus ... plus A sub I plus ... plus some final term, some final nth term. This could be a finite sum, which is mostly what we're going to be dealing with. So this is the first term. This is the general ith term. And this is the nth last term. So before we were using subscripts like N and K. Now very specifically, while we're using these different subscripts, I is going to be the subscript for the general one in the middle, and we basically reserve the nth term for being the last term in our finite sum. So nth last term in the finite sum. And we use different notation for this. Because while for a finite sum that has a few terms, that can be pretty easy to write out if there's only a couple. But as soon as you have like 100 terms, it's still finite, but it starts to become a little more difficult to write down over and over again. And this is written as the Greek letter sigma. So you've probably seen this somewhere before. Last time you were watching Good Will Hunting or something like that. This is the Greek letter sigma. It's actually the capital version of it, sigma. And it is a Greek S, and it's S for sum. So we're going to sum, but it also doesn't just say add these up. It says we're going to add up a bunch of A sub I terms. So when we write it this way, we often write that general ith form in our sum. So yesterday, when we were finding a pattern and we were writing things in terms of a pattern for the sequences, we're going to be using that pattern inside the sum. So, lots of practice in 9.1 is going to go a long way here. Now, the last thing that we need to do is tell it where to start and where to stop. And so we want our index I to start at 1 and to finish at n. So this is, again, the general ith form or ith term. This is called the lower limit. This is where you start your sum at this value. And this is known as the upper limit, where you finish or end sum here. So that's compact notation for start at A1 and finish at A sub n. And that is, oops, I guess I should have color coded that better. So this is shorthand. The notation on the right is shorthand notation for that big old sum on the left. So, as a simple example, we might write something like 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus 1 over 1/28 plus 1 over 256 plus 1 over 512 plus 1 over 1024. So if this is the n equals 1 term, and this is the n equals 10 term, what we have here is the general, so a sub 1 equals 1/2, a sub 10 equals 1 over 1024, and what we notice here is the denominator is going up by a factor of 2 each time, and so the general ith term here is a simple power of 2 in the denominator. Whoops, that should be an I. Right, that is to say it's 1/2 plus 1/2 times 1/2 plus 1/2 times 1/2 times 1/2 plus ... all the way up to 1 over 2 to the 10th power. And so this is this is our general ith term here. And so we can take this sum and we can rewrite it as the sum of all of the terms of the form 1 over 2 to the ith power, where the first power of 2 starts at 1 and the last power of 2 ends at 10. And of course, you could actually write this like this. Oops. I equals 1 to 10 of 2 to the negative I power. Be careful. Warning. I is not the square root of -1 here. I is the index or our counter. And if you think that you're going to confuse I with the index with I the square root of -1, just change the letter. You could rewrite this as k equals 1 to 10 of 1 over 2 to the k, or j equals 1 to 10 of 1 over 2 to the j power. It doesn't matter what that letter is. It's just a placeholder for your pattern and your index. So Anyhow, that's the idea. Be careful when it comes to that kind of thing. And of course, we don't have to necessarily start at 1. If I just wanted to say, add up those 4 values, I could say 1 over 16 plus 1 over 32 plus 1 over 64 plus 1 over 128 is the sum of the same pattern, where k starts at, let's see, this is k equals 1, k equals 2, k equals 3, k equals 4, 5, 6, up to k equals 7. So I could just do from 4 to 7, and it would pick those terms out of the middle. They have to be consecutive terms, but we could pick them out of the middle there. And that's the idea with that notation.